is, look, you copy only one single logarithm, only one. The base must be the same, que es a. And inside the argument, we have several things. We have z to the 7th power, because this 7 you put like spawning. Another positive is this, b times b to the 4th power. I know it's multiplication because it's plus, and 5 is w is division, no? Because it's minus, it's w to the 5th power. End the story. Any question? Do you understand very well the property or no? Come on, tell me. Everything okay or is confusing? Come on. Come on, guys. Everything is okay? Do you understand the thing I am doing? Ruth, Angelica, Ashley? Okay. Of course. Okay, guys. I sent to you, good morning. I sent to you the package, no? I suppose we are doing exactly the same. The problem que I, okay. The B is 1/2. Look, 1/2. Logarithm base 2 of A minus 1/3 logarithm base 2 of B expression plus 1/5 logarithm base 2 of C. Well, it's similar. You condense it in only one logarithm base 2 of, okay, A. I open big parentheses. Inside the parentheses, so you put in the top, the positive guy, is 8 raised to the 1/2 times C raised to the 1/5 exponent, and B raised to the 1/3 exponent. That's it. You can leave it like that. This is just cosmetic part. You can express it using radical notation, because I know that there are relationship between the fraction exponent and radical notation. This is equivalent to say square root A times, and this is a 5th root of C, and this is a cubic root of B. Either way, this is perfect and this is super perfect. More elegant, maybe. I don't know. It's up to you. Tell me, everything okay or no? Do you understand this idea or no? Okay, let's see, que es a little bit more long. El logaritmo base 5 of x plus logaritmo base 5 of y, connecting by plus, minus now logaritmo base 5 of z plus logaritmo base 5. The base should be the same. See, the base is not the same, we cannot apply the property 6, 7, and 5. Plus logaritmo base 5 of b, minus logaritmo base 5 of c. And you condense it. 1, 2, 3, 4, 5, 6. Logaritmo condense it in only one. Que es logaritmo base 5. And you open big parentheses. You put a fraction, the fraction, because I see some guy gets positive and some guy gets negative. And the guy gets positive gets x times y times a times b, no? And the top. This is b. And the bottom, the negative I. What is the negative I? Z times 6. End story. Any question? No? Confusion or clear? No question. Good. Good. Okay, let's move on to the question 10. Question 10 is completely opposite situation. We have one, so question 10 say, write the logarithmic as, well, no, it's not plural, it's only one, as a sum or differences of logarithmic. So in other words, expanding logarithmic. In this case, several. So the first example is logarithm base 2 of 1/16 W6 and P3. Okay, I suppose que the operation here is multiplication, ¿no? Entonces es basically when you apply the property number 5, es logaritmo base 2 of 1/16 plus 6 times logaritmo base 2 of W plus 3 times logaritmo base 2 of P. And the variable live like that. However, the numerical part, no. The numerical part, I need to find that. So what is, you need to find logarithm base 2 of 1/16. Remember, we can do that using the calculator, or we can do that by hand. I want to explain both ways. Okay, suppose by hand. Okay, logarithm base 2 of 1/16, I have no idea. What is the value? I have no idea. However, si I change to exponential, maybe it's more clear. The base is 2, I put a big 2. The exponent is exactly the quantity that I try to find, and it's equal to 1/16. Pero I know in that corner, que 16 we can express it like a power of 2 like that. It's to the 4th power. But actually it's not 16, it's the reciprocal. Entonces it's 2 to the minus 4. Because negative indicate flip it, reciprocal. Therefore, it's obvious that x is equal to -4, because when you have two exponential, look at that, and the base is the same, it's because the exponent is the same. It's a one fantastic way to do that. However, another fantastic way for the students that don't like that way is using the chain of base formula. Chain of base formula. The chain of base formula says, I want to copy the formula. Logarithm of the any arbitrary base, non-standard, to the x is equal logarithm of the another base, que maybe base is standard, of the same number divided by logarithm of b a. This is a formula. In our specific example, I try to compute using the calculator this logarithm. Entonces, look, associate. A is 2. 1/16. So this is equal, and you write, for example, log, pero the log common que we have available in our calculator, no? So b is 10, maybe. And you put here x get 1/16, no? And here you put a, que a is 2. Okay, so you translate from this confusing to one nice expression, que state relationship between logarithm of non-standard base, que es 2, and to a standard base. I put in my calculator. Try to do in your own calculator, guys. LOG 1/16 and -4, very well. Proof. Divided by 2. And the answer is -4. Okay. And the calculator display, I put something like that. Look. I press the key LOG. Automatically open the parentheses. You put inside 1 division 16, close the parenthesis, division, LOG again, 2, and close the parenthesis, and press enter, and the answer is, you have no excuse to compute any logarithm because we have 2 possibilities. The possibility of using the famous chain of base formula, or do it by hand, translate to exponential. So what is the final answer in our problem? Well, let me come back at the beginning. My final answer is, you replace the numerical part in -4. -4 of W plus 3 times logarithm of base 2 of P. And this is my beautiful final answer. Okay, so you leave it like that, you have the half of the credit. Always, the numerical part can involve logarithm, you need to compare the value. This is the idea. Any question? Go ahead. No, okay. Let's move on to the B problem, que is similar. B problem is logarithm of base 3 of 81 a second B6 divided by C4 times D5. Okay, and you expand. First of all, logarithm of base 3 of 81, I need to compute this value because it's numerical. 2 times logarithm of base 3 of A. Remember the exponent, go to the front as a factor, plus 6 logarithm of base 3 of B, minus, everything in the bottom is minus, 4 times logarithm of base 3 of C, minus again 5 times logarithm of base 3 of D. Now I need to focus in that part. Logarithm base 3 of 81. Suppose I make a decision to compute it by hand. You convert to exponential. The base is 3. The exponent, I have no idea. It's 81, but I know that 81 is 3 to the 4 power. Therefore, x is equal to 4. And this is equivalent to say 4. And the final answer then is 4 plus 2 times logarithm of base 3 of A plus 6 times logarithm of base 3 of B minus 4 times logarithm of base 3 of C minus 5 times logarithm of base 3 of D. And this is the final answer. End the story. Any question? Normally, inside the expansion of the logarithm, you see numerical. Okay, you have to compute it. No, this is a part of the game. Can you evaluate the numerical part? Any question? Well, I suppose that everyone get good grade in this test. Okay, normally the student believes I hear in the whole of the campus. Oh, but I never understand the logarithm. I don't know why. Not with me, another professor. y to the 6th power. Maybe with me also, no? But they don't come in front of me, no? Okay, you expand. It's a logarithm base 5 of 625 plus 5 times logarithm base 5 of x plus 6 times logarithm base 5 of y minus 6 times again logarithm base 5 of c minus 2 times logarithm base 5 of w. Okay, so my goal is compute this logarithm. In this case, I want to do using the calculator. Suppose I want to make a decision, and I change to a standard base. This is logarithm base 625 divided by logarithm of 5. Okay, entonces remember when you see one logarithm, the base, the number in the base is missing, it's because it's 10. And you put in the calculator and the answer is 4. And the final answer is you replace this by 4 and end the story. This is my beautiful final answer. Any question? How do you feel? Now, one problem of this you see in the test. Well, one problem of the condensing and one problem of the expand, opposite direction. Okay? It's clear? It's confusing? Okay. Okay. Let's move on to 11 question. 11 question is about the evaluate to 4 decimal place. I need help. This the following logarithm base 12, que es no standard, of 23.5. Okay. Now B is logarithm base 5, again non-standard, 528. And logarithm C is logarithm base 1/2 of the 44. Before do anything, I want to interpretation this. Okay, when the base is greater than 1 and the number is greater than 1, the answer that we expect is positive. When the base and the number inside is greater than 1, is positive. However, in this case, 1/2 is less than 1. When the base is less than 1 and the number is greater than 1, the answer that we expect is negative. Okay? And this is no extremely important, pero it's good to analyze. Entonces, you apply the famous chain of base formula. You compare in the calculator logarithm base 23.5 divided by logarithm of 12. Guys, and you can remember in our calculator we have two different standards. We can use it, for example, LN if you want, and the answer doesn't change, it's the same. Curiosity, let's do it in both ways. In this case, we use it again LOG 44, LOG of 1/2. And so I need help. I need participation. I need, for example, bueno, Angélica always participate. Ashley, Joel Garcia Lee. Okay, 1.21. Oh, 1.27. Let me try. 1.27. I get the first answer. 1.27, 1.27, 1.27. Let me see in my own calculator logarithm of 23.5. Close the parenthesis, division, logarithm again, 12. Close the parenthesis, press enter, bam, 1.27. Okay, but the problem is specification. Okay, they want 4 decimal place, round to the 4 decimal place. So 1 point, I copy the number, 1.2704 70431. So in my calculator, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal place. Depending, all calculators have another decimal place. Depending on the setup of the calculator, the setting. Now they want 4. 1, 2, 3, 4. See, the next digit is greater than or equal 5. You increase it. This is 1.2705. And the answer that I want. Clear? Who helped me with the second one? Who helped me with the second one? Logarithm of 528. 3. Sabrina say 3.8952, no? Let me check it, Sabrina, just in case. John Martinez, he said, okay, they are coincidence. Just in case I want to check it. Division by. LOG 5, or LN, whatever you want to use, and the answer doesn't change. Yes, you are right. Yes, you are right. Because in the display, in the calculator, I see now 3.895208529. But they want 1, 2, 3, 4. Es obvio que es 0, entonces es don't increasing anything, it stay the same, right? And the last one que I predict, it's negative 5 point. Dice Sabrina 946.94. Let me check in just in case. Wait, I'm waiting. Don't worry, I'm waiting. Okay, entonces LOG o LN, whatever you want. No, Sabrina. Erase that part. Erase. Okay, no problem. It's negative 5.4594. Let me check it just in case. 44 divided by logarithm 1/2. 1 division 2 plus the parenthesis present. And the answer I get in my display was negative 5.459494311619. 1, 2, 3, 4 decimal place. This is less than 5. Now you delete, you truncate, you eliminate that one. Super. Any question? No problema? No question. Okay. Let's move on to another topic. Let's move on to the question 12. So in the test you can see 1 or 2 see this, solve this. This is the exponential equation, no? And remember, we have two kinds. We have the regular exponential equation in which you can manipulate both sides in order to express it using the same base, or we have another kind of the exponential equation and we cannot do this, and this is the only solution that we have is apply logarithm on both sides. In this case, you can, because in one corner of the piece of paper, I know that 1/3 is 3 to the exponent -1, because -1 is reciprocal, and 9 is 3 to the second power. So we can express both sides using the common base, que es 3. Entonces 3 raised to the -1, que es equivalent, I know, to the 1/3 raised to the 2x plus 5, is equal 3 to the second power, que es equivalent to 9, x plus 3. And now multiplication, you know the property of the exponent in which when you have different level of the exponent, you multiply. So 3 times minus, it's -1 times this expression. Of course, I put a parenthesis because -1 multiply everything, equal 3 times, 2 times, again parenthesis for the same reason, plus 3. In this moment, almost we finish because we have in this moment 2 exponential functions. The base is the same. I manipulate using this intention. Therefore, the exponent should be the same. So minus 2x plus 5 is equal to times x plus 3. Okay, you convert magically the exponential equation to linear equation. So say minus 2x minus 5 is equal to x plus 6. Now manipulation, well. Suppose que minus 2x stay here. I move another 2x to the left, 6 stay, and 5 move to the right. This is negative 4x equal 11 divided by negative 4 both sides. X is equal negative 11 over 4. And that's it. And this equation, guys, you don't need to check it. This is nice because the domain for the exponential function is all real number. So the exponential equation is nice because accept any value, positive, negative, 0. The only picky is the logarithmic equation. Okay, you need mandatory to check it because sometimes happen that we have extraneous solution. Any question? Okay. Entonces, okay, no question, no. Entonces, we can apply logarithm or no? We can, of course we can, pero no necessary to do. No, not necessary. Okay, 13 is similar. 13 is similar. Look, solve again. 1 over 5 raised to the x plus 2 equal 125 raised to the x. Okay, we have again exponential equation. In one corner of the piece of paper, I put 1/5 is 5 raised to the negative 1. I know that. And 125 is 5 to the cubic. Because 5 times 5 times 5, 3 times 5 times 5 times 5, this is 25, and 25 times 5 is 125. Replace 5 raised to the negative 1, x plus 2 is equal 5 cubic raised to x. Now the property for exponent, multiplication. Minus x plus 2. Be careful with the parentheses. This is mandatory because negative 1 multiply whole thing inside the exponent. Is equal 5 times. In this case, no necessary parentheses because it's monomial, because it's binomial, yes. Now in this moment we have two exponential functions. The base is the same, nice. Therefore, immediately you translate to the linear equation. You remove the parenthesis, apply distributive property, and you solve in this elementary equation. Suppose que minus 2 stay here, 3x, I move this like a plus 1x. Finally divided by 4, finally divided by 4, so x alone is negative 2 over 4, okay, when you reduce the lowest term is negative 1. Okay, therefore x is equal minus 1. Done. Any question? No? Okay. Okay, so let's move on. Clear. Good. Okay, let's move on to the complicated part. What is the complicated part? The exponential equation. Okay, in this case 14, for example, 14. Say, solve the equation entonces if necessary round to thousands. What is the reason? Well, the reason is that in this case I know that for solving this equation 5x plus 4 equal 4x. For solving this equation, we cannot, never, express both sides using common base. The only possibility that we have is apply logarithm both sides. Because when you apply logarithm both sides, what kind? Well, standard, no? Because the last part we are doing using the calculator, no? You truncate or rounded the number to the near 1,000. Okay. Now you apply logarithm both sides. Okay. This is possible because logarithm is one-to-one function. Now you apply the property 7, que is magical. The exponent go to the front as a factor, like that. Don't forget, when you write logarithm, enclose the argument in between the parentheses. Some people frequently working like that. Everyone understands it very well, but sometimes no. So I recommend parentheses because of that, the function notation. Function notation, nobody write like that without parentheses. Now this is x times logarithm of 4. Okay, my goal is solve for x. So I apply this distributive property. You consider that this is just a number, and this is just a number. We are number, of course, but it's a number. And you multiply this times this, and this times that. Entonces, x times logarithm of 5 plus 4 times logarithm of 5 is equal x times logarithm of 4. So I try, see, I want to manipulate this. In this moment, we have no exponential equation anymore. We have linear equation. And you solve it like a linear equation. Suppose you forgot temporary the word log. We have 5x plus 4, forget about this, equal 4x. This is the equation that we have in my hand. Actually, it's not, because it's logarithmic, no? But logarithm is just a number that we can compute it with the calculator. And the manipulation is similar. For example, this stay here. I move this guy to the left. Yeah, I move this to the right. Of course, using opposite sign. No? Now factorization x. X is common factor. Well, I don't know, see, I put a parenthesis or bracket, maybe bracket is good. Logarithm of 5 minus logarithm of 4 equal minus 4 times logarithm of 5. Almost I finished because I am dividing both sides by this number. Good. Entonces we have so far x alone, is my goal, is minus 4 times logarithm of base 5 divided by logarithm of base 5 minus logarithm, no base 10, logarithm of 5 and logarithm of 4. But this answer is ugly. I don't like this answer. For several reasons. I don't like this negative. Okay, for example, to simplification a little bit that, I propose some idea. Idea number 1, multiplication by -1 top and bottom. So we have positive. It's much better for me. And you change the sign of this. Okay? And that's it. No, because it's easy for me if you condensing this logarithm and this. Why not? This is logarithm of 5 to the 4th power. You apply here the property 7. Property 7 can allow me this exponent go this factor like exponent. And here you apply the property number 6, in which you condensing this, and only one gets 4/5. Remember the positive I put in the top, and the negative I put in the bottom, right? And that's it. No. Not yet. Okay, I computed this in my calculator 5 to the 4th power. F5 times 5 times 5, oh, by hand, whatever. This is 25, no? And 25 times 25 is 625. Just in case, let me check it in my calculator. I put in my calculator something like that. 5 power 4. 5 power 4. Boom, 625. Divided by logarithm of 4/5. You put like a fraction if you want, or in decimal. By the way, in decimal is 0.8, no? But it's okay, it doesn't matter. Now ready. This is the display of my calculator now. I put log 625, close the parenthesis, division, log of 4 divided by 5, close the parenthesis. Let me try. LOG, you checking my answer is correct or I make mistake. 625 divided by LOG again, 4/5, 4 divided by 5, close the parenthesis, bam. Okay, it's negative. It's negative, and it is expecting it's negative because this number is greater than 1, but this number is less than 1. When at least it's less than 1, is negative. And the answer I get in my display, you check and see I make a mistake. Oh no, it's minus 2.88. 503 026976, and they want 1000. 1000 is 3 decimal place, no? 1, 2, 3. And this digit is 0, entonces you delete that part. The answer then is, this is approximately negative 2.8850. Bueno, 5, no 0, no necessarily put 0. This is the answer I want. Any question? What is the confusing part? Okay, it's the long process, I know. Sorry, it's not my fault. But, Professor, why do you move the decimal? Why you move the decimal? Why do you move the decimal? What decimal I move? A ver, let me see. The answer is, and my display is, see. For the answer, yes, you are right. Wrong. That is the reason I say you checking, guys. Okay, it's not 2, it's 28. The answer, I don't see well, is minus 28.85. 2626976. We have 3 decimal place, 1, 2, 3. Entonces the answer is minus 28.850. Now it's okay, Sabrina. Now, thank you. Okay, let's do it one more. Case 15. Okay, 15. 15 is similar. 15 is another exponential equation. In which is impossible. Express it, manipulate both sides. in order to use in the common base. This is important. Relative, very, very impossible. Now, basically, you apply logarithm both sides. In this case, I want to apply natural. Okay, in the real life, you apply the logarithm that you consider it better for you. But I want to say natural. It's exactly the same. This doesn't change. Okay, you apply natural logarithm, both sides. And the exponent, you apply the property 7 one more time. Go to the front. This is the beauty of that part. Can convert exponential equation to linear equation. Because logarithm of 4/3 is a number. 5x times logarithm of 5. Okay, the rest is just algebra manipulation, pero intermediate algebra. No sophisticated algebra. It's multiplication distribute the property. So ln 4/3 minus x times ln 4/3 is equal x times ln of 5. Okay, remember my goal is solve for x. I need to grouping the term that contain x to the same side. For example, this stay here, good. However, it's very, very convenient. Move this to the right, to the x plus x times ln 4/3. So now ready to no factorization. No condensing so far. Factorization. Factorization is x times ln of 5 plus ln of 4/3. Now you divide both sides by this, because my intention is isolate x. Okay, both sides. Okay, now this is cancel out. This is just x. And my goal is equal ln 4/3 divided by ln of 5 plus ln 4/3. Well, in this moment, you can put in the calculator like that. However, I don't like. Okay, I prefer using the property for the logarithm to, so you have 2, 3, 4, 5 logarithm, you condense it, no? So in the top stay the same because we have only one. But in the bottom, no. In the bottom, you apply the property number 5 because it's plus, it's multiplication, so you have the ln 20/3. Where I come from 20? 5 times 4/3. And this is easier, put in the calculator. Come on, help me, because sometimes I make a mistake. And the answer we expect is positive or is negative. What do you think? Is positive or is negative? 20/3. Boom. I get the answer. Okay, I wait for you. What answer you get? Very well. The answer is x equal, I put in the display of my calculator 0.15, 164, 1475. I want 3 decimal place, 1, 2, 3. Entonces x equal 0.15, you increasing 2. Excellent. Okay, this is the easy part, the rule of the round. See, these digits greater than or equal 5, you increasing 1 plus 1 is 2. Any question, guys? So I propose you do one more. 16, and that's it, stop. And Monday, we continue with the complicated logarithmic equation, no? Maybe I bring more example. Okay, there's one more, and that's it for today. Entonces, you say que you want que I send the test, no? Today? Now? Okay, let's do it 16. 16 is a little bit more complicated because we have one long exponential. Equation. But I realize that we have one expression que es 2 to the x here, and here we have the exponent twice. Entonces, this is classical equation que es quadratic in front. Quadratic in front is equation we studied in the first chapter. Okay, for doing substitution, so you suppose in your mind, you define que 2 to the x is u. When you rewrite the new equation using the auxiliary variable que es u, we have minus 12 here, we have plus u, and you have u squared. And now this equation is no exponential anymore. It's just quadratic equation, elementary. And this equation we can solve it by factorization, I suppose, no? Because 4 and 3 matching perfectly. 4 times 3 is 12, 4 minus 3 is 1. The sign is different, 4 is positive and 3 is negative. Then we have two solutions. U plus 4 equal to 0 imply que es negative 4. And u minus 3 equal to 0, u is 3 positive. But this is the answer? No, oh no. This is the, remember the transformation was, you have the horrible exponential equation. You realize que es quadratic in front. You make the chain of variable, and you magically, you transform it to another equation que es quadratic. The quadratic is solved by factorization or quadratic formula. Depending on the case, in this case was easy by factorization because I found the combination. However, I finish, no, I don't. I need to finish, find the value for the original variable que es x. That the original variable is x. So I split the board into parts because we have two potential solutions. The first one is to suppose u equal minus 4 and u equal plus 3. Let's do this first. I know that u is 2 to the x. So in this moment, we have one exponential equation, pero easier exponential equation. And this exponential equation is no regular, it's special because 2 and 3 never we can express it using common base. The only possibility I have in my hand is apply logarithm on both sides. One more time, we apply the property 7. It allows me the exponent go to the front. And in this moment, magically, we have linear equation. Divide both sides by ln of 2. Therefore, x is equal log of 3 divided by log of 2. Well, let me say something. You leave it like that, you can, if you want, determine the exact answer. Because, you know, logarithm of the number, okay, they are no coincidence multiple of the base, okay, the base is 10 in this case. 3, 2, no, si es 100,000, yes, it's a number, it's a real number. However, in this case, it's irrational. So sometimes you need to find no exact answer, no approximate answer. It's the thing we are doing with the calculator. No? This is approximate, and you put in the calculator, and that's it. LOG of 3 divided by LOG of 2. Boom! And the answer is 1.5862501. You trunk it around to the, for example, 3 decimal place, 1, 2, 3, and you see the next digit is greater than 5, therefore you increase it, so the answer is 1.585, no? The answer. Okay? Now this is the only answer. No! Because remember the solution for the quadratic equation for 2 solutions is -4. So you need to solve another exponential equation. Oh, in this case we can manipulate both sides. But wait a second. Something is weird in this. Exponential, the range of the exponential function never is negative. Remember, let me recall something. The exponential function looks like that. And this is 2 to the x. And -4 is the horizontal line here. Never do we have connection. Never we have intersect. So we expect that this equation have no solution. However, suppose that you don't see or you don't remember very well this idea. Okay, no problem. You continue doing exactly the same. You apply logarithm on both sides. Okay, so you apply logarithm on both sides. Nice. Okay, and you apply now the property number 7 again, yes. And you put x in the front. Okay. Equal logarithm of -4. But immediately you see mistake. Why? Because I know, or I need to know, the logarithm of the negative number is undefined. So x is equal logarithm of -4 over logarithm of 2. So you try to put this in your own calculator. I want to do in my own calculator. Depending on the calculator, we have different matrices. Error, mistake, out the domain, whatever, blah, 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 blah. Divided by logarithm of 2. I put -4 intentionally. And my calculator say error, this domain error. Because remember the domain of the logarithm function, the logarithm function domain is from 0 to infinity. So only positive, no included 0. So logarithm of 0 is out the domain. Logarithm of negative, of course, is super out the domain. Logarithm is only computed for a positive number, never for the negative number or 0. So what is the solution for this too long problem? Well, is this solution. This is the only solution that we have. This is the approximate answer, and this is the exact answer. Depending on the question, so you want the exact answer or you want the approximate answer. But we stop here. Well, the time is over. We stop here. Okay, now I want to send the test. So you start working in the test, no? Okay, here is the test. Okay, test number 4. There you go. You let me know if you receive or no. So you receive, you say, Professor, I got it, and you can leave. Otherwise, stay reset again the test. Let me see my phone. Got it. Okay, super. Got it. Okay, bye guys.